One way of solving quadratic equations is a pretty easy method. You notice this problem here. This whole quantity is squared, and the directions are, of course, solve. So to solve this, you can basically take the square root of both sides. So you take the square root of x plus 3 squared equals plus or minus the square root of 5. The square root of x plus 3 squared is x plus 3 equals plus or minus the square root of 5. Continue solving for x. X equals minus 3 plus or minus root 5. Another way to write this, you could write it as two separate answers. Minus 3 plus square root of 5 and minus 3 minus square root of 5. Both answers are the answers to this quadratic equation. Alright, here's another one. Again, the first step, take the square root of both sides. This side's easy. The square root of a quantity squared is that quantity. On this side, I have to take the square root of a negative number. I can't, so I turn it into an imaginary number first, and I rewrite it. I root 4, and the square root of 4 is 2. Oop, I forgot, plus or minus. Whenever you take the square root of a side, it could be plus or minus, because this whole quantity is squared. So I don't know if it was originally a positive number or a negative number. So to account for that, when you take the square root of both sides, you must put plus or minus to account for the fact that it could have been a plus squared or a minus squared. All right, so let's continue this problem. So we have plus or minus I root 4. Square root of 4 is 2. So I end up with x plus 5 equals plus or minus 2i. Again, I need to continue solving for x, so I subtract 5 from both sides. X equals minus 5 plus or minus 2i. So x could equal minus 5 plus 2i, and x could equal minus 5 minus 2i. Both answers are correct. So let's adjust this a little bit so you can see that. All right, let's do one more. X squared equals 16. How do I solve that? Take the square root of both sides. The square root of x squared and the square root of 16. Now, because I don't know if x was positive or negative, I have to account for both possibilities here. So I put plus or minus. X could equal plus or minus 4. We can check that. 4 squared equals 16. Minus 4 squared equals 16. Maybe this example makes it easier to understand that when I take the square root of both sides, even though the principal square root of 16 is 4, because I didn't know what was squared on this side, it could have been 4 squared or negative 4. I have to always put a plus minus when I solve by doing the square root of both sides. Now this was nice for all of these problems that had something squared on one side, but how do you solve that quadratic equation? It doesn't have the whole side squared. Now, if I move this over, it doesn't help me because then I would end up with the a inside the square root symbol. So there's another method we can use. We can find the perfect number that could go here. 3 is not that number. That would make this trinomial a perfect square so that it could be written as a binomial squared. Watch how we do this. First, I'm going to rewrite the problem. Plus a space. I'm going to find a new number to go there. And I'm going to put this 3 on the other side as a negative 3 plus a space. I'm going to find a new number, but whatever I add to this side, I must add to the other side. So let's figure it out. Do you remember how to find that? 5 over 2 squared is 25 over 4. So 25 over 4 is the number that goes here. And I have to add 25 over 4 to this side. Now this factors into a binomial squared. You know what that is? A minus 5 halves. That's why it's always good to show you work for the step and leave it there. Finishing this problem, minus 3 plus 25 fourths is 13 fourths. Now, let's take the square root of both sides, just like we did for all of these problems. So take the square root of this side and the square root of this side. Now, the square root of this quantity squared is a minus 5 halves equals. Now remember, I have to put plus or minus because I don't know if the original was a positive or a negative, so I have to account for both. And when I take the square root of that, I'm going to separate. Square root of the top is square root of 13. Oh, I can do the square root of 4. That's 2. Now, I still have to continue solving for a. So a equals, I'm going to add 5 halves to both sides. So plus 5 halves plus or minus root 13 over 2. And that is 2 answers. It's 5 halves plus root 13 over 2 and 5 halves minus root 13 over 2. Since I can't really add any like terms, it's acceptable to leave your answer in that form.